All right, so today we are multiplying and dividing rational expressions, which you guys probably already know because you've been solving some equations, but it's just a good refresher how you simplify and make sure your equation is algebraically sound, right? So you'll have things where it says simplify this, right? So you already should be thinking, well, I can factor some of that stuff. So for example, for the top one, I'm already seeing that I can factor out an x to make it a squared function, right? And I'm also seeing I can do the same to the bottom. All right, so what am I noticing? Well, I'm noticing I can cancel these out, right? Because x over x just makes 1. And so now let's factor again. Because this works out, right? This is x minus 8 and then x plus 3. Yep, that gives me that 5 in the middle. And then down here, I'm noticing I can do plus 9 and minus 8. Again, so I can factor these out because x minus 8 over x minus 8 is just 1. So this whole thing simplifies to x plus 3 over x plus 9. Okay? But the domain of the original equation is still true, because if this is your final function, it looks like your domain is everything but x equals negative 9, which is true. X cannot equal negative 9. But you also have to include the limiting factors of the original equation, right? So originally we had an x in the denominator, so that also means that x cannot be 0. And then here we also factored out a minus 8, x minus 8, so that means also x cannot be 8. So this is true. We would say true except for x equals minus 9, 0, or 8, or you could say it like that, right? And the interesting thing, I think you guys should try to do this on Desmos, but I'm going to do it on my graphing calculator, and of course I'm not prepared, so let me just type it. Divided by x cubed plus x squared minus 72x. I'm just, of course it all ended up in my exponent. So this is x cubed plus x squared minus 72x here. I'm just typing this in, sorry. So when I graph that, you can see there's the function, right? So let's see what happens at x equals 8. So if you're on one of these, you can go second, calculate, and we want to go to an exact value. We want to go to x equals 8. So I type in x equals 8, and you can see it doesn't give me a y because it's not defined there. And really, if you look at it at x equals 8, it looks like there's a, it continues, but it's not. It's actually a hole. So you can actually see the hole much better on Desmos. You'll see the function go, continue on, and then at that point, there'll be like one of these, it'll end up looking like this, right? Like a little open hole, because there is no value at the function at x equals 8. The same would be true for negative 9, and the same is true for 0, right? We can see, what is it at negative 9? Is it negative 9? Yes. It's actually trace, because you can see there's no value, but what happens if we trace this function? So you could see actually negative 9 is where there's an asymptote, so that makes sense, because that's what would happen if we solved for negative 9 here, right? And same, but what if we plugged in 0? There is no asymptote, but there is a hole. Okay, so that's what's happening with the graph when you factor things out. It's showing you that there's a hole there. So let's keep simplifying. Okay, what if you had to simplify this? Well, I'm noticing that I can take the numerator and factor it to that. I can take the denominator and I can make it x minus 5? No, x plus 5, x minus 2. Right, so right now it's looking like nothing can factor out, but I know I can rewrite this as, if I rewrite this with the x first, I can take out a negative and it would become x minus 2. See that? which is helpful because now I can factor it out there. My second one becomes x plus 2, and then I still have x plus 5 over x minus 2. Now the only reason I did this to that first expression is because I wanted to cancel it out. That was my goal, was to be able to do this. So what's my answer? My final answer is negative x plus 2 over x plus 5 for all x except x is equal to minus 5. And what else did we factor out of here? X equals 2. So this is true. The simplification is true except for all of the x's that are outside of the domain of the original function. Okay, what about this one? This one we've got to multiply first. Okay, let's multiply. If I multiply 2xy times 3x squared, I just end up with 2xy times 3x squared over, remember we just multiply all this, 4 times y, then we've got 2z's, which I could have done that up here, but my brain wasn't working correctly, so 3 times 2 is 6, then we have x cubed y over 4yz, it's a z, squared. And now I'm noticing I can take this y and cancel out with that y. And I can also divide this by 2, right? So I end up with 3x squared over 4z squared. And it's for all x except for when, it's for all values except y cannot be 0, right? I'm looking up here. And z cannot be 0. Okay, so now let's keep going. Simplify this. All right, well, x plus 2, I can't do much with that. Oh, I only wrote half of the equation. No wonder that looked so easy. It was supposed to be multiplied by this. I didn't leave myself enough space. Okay, so let's go ahead and multiply it out. So we end up here with x plus 2 times, well, I'm going to actually factor an x out of this. It's going to be x times, so really it's multiplied by all of this, x squared plus 4x minus 12. And all of that is over x to the 4th minus 16, which I know I can rewrite as this. Right? Because it's just multiplying fractions. You multiply the numerator and you multiply the denominator. This is just over 1. Okay, so why am I doing this? Because I'm hoping I can factor some stuff out of here. So this is equal to x plus 2 times x times, this is x, what am I need a 6 and a 2, right? So I got x plus 6, yeah, and x minus 2, all over, well, this one, x squared minus 4, I know I can make x plus 2, x minus 2, and then let's just leave the x squared plus 4 there right now, because I'm trying to see what I can factor out of here, right? And so I know I've got this plus 2 and that plus 2 can factor out this minus 2 and this minus 2. So there's really no reason to factor this because I have this plus 6 up here. It's not really going to factor out with anything. So what am I left with? I'm left with x times x plus 6 over x squared plus 4. And that is true. So we can say true for all x except what? What's not in domain when I look up here? X equals plus or minus 2. It's actually the same. No, yeah, it doesn't matter here. It's just for this minus 1, right? All right, so now what about division? This is the same thing. It's just a little bit more tedious because you've got to keep track of your work, okay? So this is the quotient of this rational function and this one. So if I rewrite this, over 1 minus x squared. So now hopefully you remember your fraction division. Instead of saying divided by this, remember you keep the first fraction the same, you change multiplication to division, and then you flip the second fraction over. It's still true for these rational expressions. I'm just going to flip it over. Multiply by the reciprocal. Remember that? Keep, change, flip. Okay, now we're just going to do what we did before. But instead of multiplying all this out, I can see a nightmare, right? So I'm going to try to see if I can factor and cross cancel anything first, right? So I'm going to deal with this guy. I'm just going to do a little thought bubble and do some work with it over here. And then we'll deal with the rest later. Okay, so it's this cubic function. So remember the list of possible zeros that you could find. This is from your last unit. So the list of possible zeros would be the coefficient of your last term and your first term. So that would be plus or minus 1 over, that's also a 1, over plus or minus 1. So my possible zeros are really plus or minus 1. So let's just pick one. Let's try x equals minus 1. See if it's a factor. So to see if it's a factor, we are going to do synthetic division. So I'll take the coefficients off of that. 1, 3, 3, 1. 1 times negative 1 is negative 1. That's 2 times negative 1 is negative 2. That's 1 times negative 1 is negative 1. That's 0. Yes, it's a factor, right? I don't have a remainder. So I have just factored out this top part to be what? X plus 1 times x squared plus 2x plus 1, which I can actually factor again to be x plus 1 times x plus 1 times x plus 1. Right, this thing actually ends up being x plus 1 cubed. Okay, so that has helped us because now I can rewrite that. So I'm going to rewrite this as x plus 1 times x plus 1 times x plus 1. All right, and that was all over. I'm just going to rewrite everything else as it was, and then we can deal with it. That, and it was being multiplied by this. Okay, so now let's factor it more. So we have x plus 1 times x plus 1 times x plus 1. And this, right, this can be factored into, let's take the negative out. So we'd have x squared minus 1, right? And this is going to be times, well, I can factor this. This is going to become x plus 4x minus 1. I can also factor this. It's going to become x plus 4, x plus 1. And then I can also factor this. Right, this becomes negative, and then it's of x plus 1, x minus 1. Okay, so I've done all my factoring. Now I can cross out things, right? So this x plus 1 can cancel out with this x plus 1. This x minus 1 can cancel out with this x minus 1. This x plus 1 can cancel out with that x plus 1. This x plus 4 can cancel out with that x plus 4. So what am I left with? I'm left with x plus 1 on the top and a negative 1 on the bottom. There's still this negative here. So what is this? This is equal to negative x plus 1. And it's true for all x except x cannot be. Let's go back and look at the domain. Let's flip. Right, so if I look here, x cannot be positive or negative 1. And then x cannot be whatever makes this 0 as well. So when I come over here and look, that's also, it's still a minus 1 and also a minus 4. All right, so this is just remembering all your factoring and keeping all your work in order. See you next time.